Welcome to our channel. In this session, we are going to discuss about the problem Sqrt of x. The name specifies it is square root of the number x. Read the question carefully. Given a non-negative integer x, return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. What is the meaning of this one? For example, I given a number 16. What is the square root of 16? 4. Suppose number 25. Square root of 25 is 5. Suppose number 8. So number 8, square root is not an integer value. It is a floating value. But the question is, even though it is a floating, return the integer that is rounded down to the nearest integer. In 2.82842, this is the square root of 8. What is the nearest integer? 3. But the question is down. So, nearest integer is 2. And one more thing is you need to solve this problem without using any built-in operator, built-in functions. Now you need to solve manually. Now we will discuss how to solve this one. Okay. Now, before solve that one, I will explain the concept of binary search. What is a binary search? They given some set of elements. Already all the elements are arranged in ascending order. Assume the elements are from 1 to n. The elements are from 1 to n. You have n number of elements arranged in ascending order. And they given a key. Your aim is to find the position of key. To find the position of key. What is the approach I follow? Instead of blindly checking the key with the first element, second element, so third element, and so on, instead of checking in the worst case all n number of elements, first I am calculating the middle value. Here this is assumed as low, this is assumed as high. That is the lowest value, highest value. Next I am calculating the middle position. Now, our key is compared with mid value. Assume the array name is sum A. Our key is compared with middle position value. If both are same, what is the answer? Mid is the answer. If both are same, I am returning mid. So the answer is available at mid position. Now understand the concept. For example, if the key is less than the value at the middle position, less than the value at the middle position, that means my key is in this range only. Yes or no? Key is less than mid. In this range only, suppose key is greater than mid, my key is in this range only. That means either this one is satisfied or this one is satisfied, whether it is less than mid or greater than mid. Now understand, if it is less than mid, we are searching only this part. That means what is this part? This is low. This part, mid is not at all required. Mid -1. This part only low to mid -1. So this mid -1 becomes high. Or you are searching this part. What is this part? Mid +1 to high. That means low becomes mid +1. Each and every time I am updating low and high. If key is less than mid value, my high is reduced to mid -1. Suppose if key is greater than mid value, my low is moved to mid +1. Each and every time we are doing half of. Exactly In the similar fashion, we are doing this operation. Okay. Now, I will explain this algorithm or procedure with two examples. First, take x is equal to 6, and then we are moving x is equal to 8. Take x is equal to 6. How I will write? Low is one value. Initially, assume low is equal to 0. High is equal to x. According to the example, low is equal to 0, high is equal to 16. Here I will repeat the loop. What is the condition? I will explain the condition later. Suppose I will repeat the loop. The first step is within the loop. The first step is calculate mid value. Here, not the positions. Here, I am given the values only. Now, what is mid value? 0 plus 16 by 2. That is 8 is the mid value. Now, square root. Here, what is my logic? In case of square root, multiplication of two numbers is given. For example, 4 into 4, 16. 5 into 5, 25. If I am getting some mid value, mid into mid is equal to the given number, means that is the square root. Now, instead of previously compared with single position, but here multiplication of two numbers according to this one, if mid into mid is equal to x, written mid. So 8 into 8 is equal to 16. 8 into 8 is equal to 16. Condition false. Else, if we are checking after multiplication, if this value is less than 16 or greater than 16, suppose mid into mid value is less than x. So 8 into 8, that is 64, is less than 16. The condition is false. So the condition is false in the sense that mid value is greater. Now you need to reduce your high value. Suppose, see, else 64 is greater than 16. Understand carefully. By multiplying the two numbers, the value is greater than. That means what you need to do? You need to reduce the mid value. You need to reduce the mid value. Why? 64 greater than 16. Immediately I am converting high is equal to mid minus 1, 7. What is the reason? Already multiplied with 8. It is a greater value. Now you need to multiply less value. Multiplied with less value. In case of less value means that is less than mid. Suppose in case if it is less than at any point, now already that value is less than. To maintain equal, you are incrementing. Low is equal to mid plus 1. Anyway, move to the next iteration. Suppose here the condition is satisfied. Assume the condition is satisfied. That is low is equal to 0. What is high? High value is equal to 7. Mid is equal to 0 plus 7 by 2. 7 by 2, 3.5. This is the floor operation. Mid is equal to 3. So 3 into 3 is equal to 16. No. 3 into 3 is 9. 9 equal to 16. No. Now 3 into 3. 9 is less than 16. Yes. 9 is less than 16 means our value is greater than mid. Then immediately what I am doing? Low is equal to mid plus 1. Low is equal to mid plus 1. What is high value? High is not at all updated. In this example, only else if is satisfied, low is equal to 7. Again, next iteration, low is equal to 4, high is equal to 7, mid is equal to low plus high by 2. 4 plus 7. What is the 4 plus 7? 11 by 2. 11 by 2 in the sense 5. 11 by 2. 5. So 5 into 5 is equal to 16. No. Now 5 into 5, that is 25 is less than 16. That is also no. We are moving to else part. What is else part? High is equal to mid minus 1. High is equal to 5 minus 1. That is 4. Coming to the next iteration. Next iteration, low is equal to 4 and high is equal to 4. Now, what is mid value? 4 plus 4, 8 by 2. Sorry, 4 plus 4, 8 by 2. That is 4. 4 into 4 is equal to 16. Yes, the condition is true. Return mid. Return mid, what is the answer? Answer is equal to 4. You got it? This is the logic. Here we are repeating the loop until low less than or equal to high. Whenever low crosses high, no use. Exactly. We will discuss the same thing for element H. Now understand what is low is equal to 0, high is equal to h, low less than or equal to h. The condition is true. First to calculate mid value, 0 plus 8 by 2. Mid is equal to 4. 4 into 4 is equal to h. The condition is false. That is 4 into 4, 16 is less than 8. The condition is false. 16 is greater than 8. In this case, what happened? The last else, high is equal to mid minus 1. High is equal to mid minus 1. So, high is equal to 7. Repeat the next loop. Low is equal to 0. High is equal to 7. 0 less than or equal to 7. Mid is equal to 3. 7 by 2 means 3. Now, 3 into 3 is equal to 8. No. 9 is greater than 8. 9 is greater than 8. Now, high value, if the value is greater means you need to reduce the left part. High is equal to mid minus 1. 3 minus 1, 2. Move to the next iteration. Low is equal to 0. High is equal to 2. Mid is equal to 2 by 2. That is 1. Mid is equal to 0 plus 2 by 2. That is 1. Now 1 into 1. 0 less than or equal to 2. Condition true. 1 into 1 is equal to h? No. 1 into 1 is equal to 8? No. Now 1 greater than 8. This condition is false. 1 less than 8. That means my low becomes mid plus 1. My low becomes mid plus 1. In the next iteration, low is equal to 2, high is equal to 2. 2 less than or equal to 2. Now, mid is equal to 2 plus 2, that is 4 by 2. 2. Clear? Now, 2 into 2 is equal to h. The condition is false. 4 is less than 8. Yes, 4 is less than 8. Now, low becomes 3. Move to the next iteration. In the next iteration, low is equal to 3. High is equal to not updated to. What is the condition? Low less than or equal to high. Condition failed. Condition failed. Once the condition is failed, in the sense it is not possible to find out. That is for that particular number. So fractional, that is a floating, is available. Once the condition fail, here you are not returning mid. By coming out of the loop, you return high. That is the highest value we are getting. What is the high value in this example? I is equal to 2. That is the answer. For the 8, 2 is the answer. Yes or no? Think you got it? If you get the exact factor, then middle is the answer. If you are not getting the exact factor, then we are returning the value. What is the value? According to my example, I used highest value. If you change the notations low equal to mid plus 1, high minus 1, you can return low also, whatever it is. Now, execute. Initially, I assumed low is equal to 0, high is equal to x. Directly, I taken the value and I am repeating the loop. Why? At some point, you need to close low less than or equal to high. First step, calculate the mid value. Low plus high by 2. Once the calculation of mid value, compare if it has exact factor or not. If mid into mid is equal to x, that is exact factor is available. In this case, directly you are returning the mid. L if mid into mid value is less than x. What is the meaning? After multiply the two numbers, if the value is less than x, in the sense we are our value is the smallest value than mid. You need to move to the right side part of the mid. So low is equal to mid plus 1. Else in the sense exactly reverse. High is equal to mid minus 1. Such the last part. Once you coming out of the loop, so if you are not returning any value in the loop, you need to return the value high. Why? Because according to my logic, high consists of the nearest integer. Now, run. See, accepted successfully. Now, submit this one. See, submitted successfully. This is the way. That is, if you already everyone know binary search, apply one concept in another program. This is the point here. Okay. That is the end of this program. Thank you.